From the moment humans started building, we've always aimed higher. From the ancient pyramids to modern skyscrapers, the desire to construct the tallest structure has pushed the limits of engineering. But is there a limit to how tall we can build? Could we construct a building that reaches beyond the clouds, even into space? Let's find out. A history of reaching new heights. The earliest record of monumental construction dates back to the Great Pyramid of Giza, standing at 146 meters when it was completed. It held the record for nearly 4,000 years until Lincoln Cathedral surpassed it. Then came the Industrial Revolution, giving rise to skyscrapers, culminating in today's Burj Khalifa, the tallest building in the world at 828 meters or 2,717 feet. But half of a modern skyscraper isn't even livable. The higher you go, the more space is dedicated to mechanical floors, elevators, and structural support. The livable space in a super tall building is typically around 50%. This becomes a major challenge in constructing taller buildings. Eventually, the structure becomes more about sustaining itself rather than being functional. How tall could we go? To answer this, we need to consider both technical and natural limitations. The tallest mountain on Earth is Mount Everest, standing at 8,849 meters. It exists because of tectonic forces, but if we wanted to build a tower of that height, we'd need materials far stronger than anything we currently use. The weight of the upper floors would crush the lower ones unless we used advanced materials like carbon nanotubes or graphene. The X-Seed 4000 was a concept for a megatall skyscraper. It was designed to reach 4,000 meters for Tokyo, Japan, by the Taisei Corporation in 1995. Inspired by Mount Fuji, it would house up to 1 million people. But even this design faces immense engineering challenges: the effects of gravity on people living at different elevations, and the logistics of supplying resources to such a massive structure. Real ambitious project, which is already visible, is the Jeddah Tower, originally planned to surpass 1,000 meters and become the first kilometer-high building. Located in Jeddah, Saudi Arabia, construction started in 2013, but has faced multiple delays due to financial and logistical challenges. The development halt stemmed from labor problems, with a contractor following the 2017 to 2019 Saudi Arabian purge. The construction restarted in January 2025, and it is estimated to be completed in 2028 or 2029. Meanwhile, the United Arab Emirates does not want to lose its status as the country with the tallest structures in the world, so they have been working to make the Dubai Creek Tower a reality. Designed to exceed the Burj Khalifa, this structure is inspired by the Islamic architectural tradition, specifically the architecture of minarets and natural lily flowers. Although the final height remains undisclosed, estimates suggest it could reach 1,300 meters or 4,300 feet. The groundbreaking for the tower began in October 2016. However, construction has faced multiple delays, raising doubts about its completion. Wind, cost, and technical challenges. Wind becomes a massive problem at higher altitudes. Skyscrapers today already sway due to wind forces, but at extreme heights, the wind can exert enormous pressure. To counteract this, engineers use tuned mass dampers, huge counterweights that shift to balance the movement. However, at several kilometers high, these methods may not be sufficient. Then there's the issue of cost. The Burj Khalifa cost around $1.5 billion to construct, and a structure even twice as tall could cost exponentially more, making it financially impractical. Materials, transportation, and maintenance costs rise dramatically as height increases. Beyond skyscrapers, the space elevator. Instead of building taller and taller, what if we rethink the entire concept of vertical structures? One alternative is the space elevator, a theoretical structure that extends from Earth's surface to geostationary orbit, around 35,786 kilometers high. Rather than being a massive tower, it would be a tethered cable with a counterweight in space, allowing for smooth transportation into orbit. The biggest challenge here is materials. No known material is strong enough to withstand the tension required for a space elevator. Carbon nanotubes and graphene are promising candidates, but we're still far from creating cables long and strong enough. Conclusion. So, is there a limit to how high we can build? Technically, no, but practicality and physics impose serious restrictions. If cost and materials were no issue, maybe we could theoretically build up to the height of Everest, or even beyond. But instead of purely chasing height, the future may lie in smarter, more sustainable cities that optimize space and energy. Many architects and engineers are now focusing on eco-friendly skyscrapers, integrating renewable energy sources, green spaces, and efficient resource management to reduce their environmental impact. The buildings of the future may not just be taller, they may also be greener, blending cutting-edge engineering with sustainability. Whether through megastructures or innovative urban planning, humanity's drive to build will always continue to evolve.